My name is Boris Gurenik. I'm a data scientist and data visualization consultant. And welcome to my before and after data visualization series. In this video, I will show you how one can drastically improve a graph if they ask the right questions and follow a set of simple rules. The example you will see here is based on an actual question that I was once asked. I changed the labels a little bit and the numbers in order to keep trade secrets, but the result is nevertheless is a real-life example. First, I will show you all the steps from the beginning to the end, and then I will show you how I implemented those steps in code using Python. Let's start. This is a graph that I was shown, and the person who showed me this graph asked me how can I improve this graph. And my first question was not how to improve the graph, but what does this graph mean? What is the conclusion of this graph? And the person told me that they used they enhanced a training set for their machine learning task, and this enhanced training set reduced actually the overfitting of the machine learning algorithm, and the reduced reduction in overfitting is a huge thing, is a very good thing. So I asked this person to formalize this conclusion in a short sentence, a sentence short enough to fit as a title of this graph. And this is the title that we selected, and the title says "Improved Performance with Enhanced Training Set." It is short, concise, and it delivers the message that this person wanted to convey. But then I asked this person, what's now? Do you think this graph delivers this message? And we decided that the answer was not, because you cannot actually see this huge improvement as the main message of this graph. So we decided to make some sketches. And this technique is something that I call a pseudo chart. In this technique, we use a pen and a pencil and a sheet of paper or a tablet, and we just scribble. So I told my friend, you know, you use the metric called F-score. F-score is a metric widely used in machine learning, in classification problems. So I said, let's put the F-score on the x-axis. Now we have several classes of problems that you solve. Let's call them class A, B, C, D, etc. We will have, I don't remember, maybe 6 of them. So the thing is that the enhanced training set of my friend led to improvement in F-score in all the cases. And a better F-score is a higher F-score. So we will be able to draw this F-score using a dot for the beginning, a line, and a triangle for the end. And you will see that this triangle creates a sense of an arrow and of a direction. And this way we will be able to show the audience of this graph that there is an actual improvement, right? And we will be able to show the magnitude of the improvement in all those data sets that my friend and colleague wanted to present. And now the focus will be on the improvement and not on the values themselves. So we decided to go with this strategy. And this is the result that you see in your screen now. And on my point of view, it's much better. It's more readable. It produces better results in that it conveys the main message in a clearer way. But of course, this is not an ideal graph. It has problems here and there. And the first problem is the readability of the text is a little bit problematic. So to improve the readability, first of all, I will sort those cases to make the comparison of values that are close one to another easier.
And I will also, in the next step, I will reduce the data I will increase the data ink ratio. I will increase the signal to noise ratio, which means I will remove all those graphical elements that are not needed in this graph in order to make this graph more readable. So as you can see, I removed this rectangle frame around this graph, right? And now the graph contains less ink and it is therefore less distracting. Now I will make this graph even more readable by making sure that the text that the user reads is not rotated, so that they don't need to tilt their head like this. Okay? I will also translate this this category names, which are, I mean, they're pretty obvious to the person who constructed this data visualization, but not to the audience. So I will translate those. Categories into human readable format. I mean, in actual sentences that or phrases that actual humans use. And as one of the last steps, I will introduce some hierarchy to the graph so that everybody can distinguish between the data and the navigation information. And this hierarchy is also called sometimes information layers. So you can see now that the labels of the X and Y axis are now gray, so that they are less distracting. Okay. Now note this that we don't actually need this vertical y-axis because it's unneeded. The lines create visual the visual hierarchy, and this y-axis is not needed anymore. Also note that we don't need that many ticks on the x-axis, so I will remove them too. Also take a look at how I remove this legend. Instead of the legend, now I have the explanation of what the point means on the graph itself. By removing the legend, I remove the need to move the eyes from the graph to the legend, from the legend to the graph, and that's how I made this graph even more readable. Okay? So by following those pretty easy steps, I managed to create a much better graph in my point of view and in point of view of many other people who saw those before and after versions. Okay, so compare those two graphs. The before graph emphasizes the actual values, while the new graph emphasizes the comparison. The before graph contained a lot of unreadable text, by that the text was rotated, and it used categories that are hard to read. And the new graph contains only horizontal text in a human readable format, and also it contains a title, which means that the audience sees the graph and immediately understand what is it that the person wants to convey. Okay, so this is it. If you know how to code and you want to see how I made those changes in Python, stay with me. And if not, goodbye. See you in my next video. And meanwhile, don't forget to visit my blog, gorelik.net. Bye-bye, but don't go if you want to see how it's done in Python. So now I'm about to show you how I implemented all those steps that you saw in previous section using Python code. So we are now in a Jupyter notebook. Here we have some data. The data, as I said, I changed a little bit the data and the labels so that the secrets are well kept with me. And this is more or less the standard approach to visualize two groups of numbers. We here used a bar chart, using two different colors, and you can see here we have some labels, x-axis, y-axis, the standard stuff, right? And again, I remind you, I asked my friend, what is it that you want to say to tell us? And the friend told me, well, you have an enhanced training set, and this enhanced training set reduces overfitting. That is why the overall performance is much better. And they said, well, yeah, but it's not, it's too long. So we came up with a very with a shorter and very precise sentence that says an improved performance with, improved performance with enhanced training set. Okay, so we have this graph. The graph is identical to the previous graph that you saw. I just added the title here using this line of code. Okay. And now the question is, does this graph convey this message? And I claim that it doesn't. It doesn't. There is a better way to do this. And again, I already showed you how I sketched my pseudograph. You can go back in this video and take a look. So the general approach would be to plot the f-score, the metric, using the x-axis, and to use the y-axis to convey the categories. And we have here the original point as a circle, and the final point is marked using a triangle. And we have a nice legend here. Let's take a look how I did this. So I created a graph and an axis object in this line, in the first line in this cell. My y coordinate will be the index of this data frame. So the data frame is an index data frame, and in this case the index of this data frame, as you can see, is numbers from 0 to 6. We have 7 categories. And in this for loop, I am iterating over the rows using the data.iterRows function, and this iteration generates two elements. One, ix, is the index, and the other one is the actual row in my data. So now I can plot this data, and you can see my x numbers are the baseline and the enhanced performance, and y is the index. We have identical index. This dash means that we will use a line, hence the dash. And we will use the C0 color, which means the first color in the set of colors that is used by matplotlib. And we will not use any label for this graph, for this element. So this for loop generates seven lines. Let's do just this, and you can see those 7 lines. It's not that nice yet. But we also wanted to create the dots, the initial and the final dot. And we achieved this by adding those two plot statements. So we plot the baseline on the y coordinate using a circle, and I color the circle in gray, and they created here a label so that we will have an automatic legend. And the second line generates the enhanced numbers using a triangle. That's how we create a triangle, using the greater than character. Okay, and we use the C0 color, and you can see the result right now. So I could have used another. So to generate the triangle in the opposite direction, we use the less than. And we can use, of course, upper triangle, but in this case, we have a very convenient way draw an arrow. Okay. So ax.legend generates the legend, and that's since we in this loop. Can you see this loop? In this loop, we didn't use any label. We specifically told matplotlib not to use any label, so we only have two labels. And now then when I run this graph, matplotlib will generate this legend for me, and it is smart enough to put this legend at the place where it interferes the less. And actually, this is not a bad graph. It's much better than the previous one, and if you don't have enough time, well, it's a decent graph. You can use it if you're in a hurry. But if you want to make your graph even better, if you have more time, I say you should improve it. Okay, so the first, and it is a very easy step to perform, and the result and the effect is tremendous. The first thing is to sort the graph according to some value, the most important value, if you have several values to choose from. And in our case, the most important value is the final F1 metric. So now I am sorting all those lines using this final F1 metric. And by sorting, not only do I create a graph that is visually more pleasable, I also make it easier for people to compare the numbers, because the sorting implies order, hence the sorting, right? So now it is much easier to realize that this data set has higher or equal F1 score than this one. Okay, so sorting is easy to do. And it's cheap to do it. I mean, it's very easy. It doesn't take too much time, and the result is tremendous. Now I'm starting to reduce the signal-to-noise ratio, which means I remove those elements in the graph that have no real effect, and their only effect is that they're just there. And if they're just there and then don't convey any information or do not help navigating this graph, that means that they're just disturbing. So first of all, I removed this rectangle around this graph. It is very easy to do. All we need to do is to import the library that is called Seaborn. You can see my import statement here. So we have a graphical library Seaborn. It is usually abbreviated as SNS. And among other things, Seaborn provides a very useful function that I like very much, that is called dspine. What this function does, it removes the spines from the graph. So a spine in matplotlib terminology are those lines that surround the graph area. So if you don't say anything to matplotlib, it will despine. It will remove the upper spine and the right hand spine. Next, I will show you that we will also remove the left hand spine too. Okay. And now I would like to improve the readability of the text. So what I'm doing now is I am creating a much more readable label. So as you can see here, the label is still the label of the y-axis is still rotated, and people actually need to tilt their head in order to read it, which is not a good experience. So let's help them. So what we are doing here. So this is the line that generates the y-axis label. I am splitting the label into rows, hence you can see here this \n for new line. I put my label at the 0 position on the horizontal axis, and this is the most important part. I tell matplotlib not to rotate the graph. So the default is to rotate it 90 degrees. This is the default, but I don't want it to be rotated. HA means horizontal alignment. It aligns the text, the label itself, and MA means multi-line alignment. it aligns the several lines within the same text box. And the result is, as you can see here, a much more readable y-axis label. Okay, and again, it takes some time to learn how to use those y-label parameters. But once you know how to do them, it doesn't take any time at all. Okay. Now, I think that this step is not required one, but it is nice to have. I decided to translate the labels that appear in my data set as basically it's a machine code, right? So it is easy to operate on when you are writing programs, and you kind of know what they mean when you analyze this data all over again every day. But once you generate a graph and you want other people to see it and understand it, it's better, it's a good thing to make those labels more understandable. Okay, so instead of saying, for example, upgrade 7D, I said here, upgrade in 7 days, etc. And it looks like it's a small thing to do, but it makes the reading much easier for our audience. Okay, so I have this is a dictionary, it's a standard Python object, and I populate my data with these new labels using the apply function. There are many ways to do this, but I found it an easy way to do. So I apply the function, this lambda function, on the classification category column, and the result is that now I have an additional column in my data. I called it category English because now it's in actual English language and not machine code. And the code itself stays the same. So I create those labels like this. You can see here I create the y ticks. Each tick on the y-axis is generated by this line, and y contains all the numbers from 0 to 6. And I generate the tick labels using this line when I say ax.set y tick labels, and I provide the labels. Of course, if I want to generate labels for the x-axis, I will use set x tick labels. Okay, it's not that difficult to do. Now I notice that I have here somewhat competing text. So we have this text that this category text, and we have here the text that designates the explains what those strings are. So one way to improve this competition is to remove the y-axis, the y-axis label. If everybody understands that it's a category, maybe we don't need it. But here I wanted to keep it here, and I also wanted to make sure that the audience knows what the x-axis means. But on the other hand, I want to put them on the background, so that the audience sees the data, and if they want to know what the meaning of the data is, they go to another sort of layer of information, and that's how they navigate into this graph. This approach is called information layers, and it creates hierarchy, and it is a very useful approach that improves the readability of a graph, and hence makes it easier to you to convey your message. And you can see here we have gray labels and we have black labels in the foreground. Okay, now I want to improve the. Okay, now I want to improve the signal to noise ratio even more, and to do that I am removing the legend. You can see here I'm commenting out the legend, because a legend is sort of a good thing, but it's an evil. I mean, sometimes we have a legend, to have a legend, but usually we can do much better job without the legend. So what I'm planning to do, I will put those text labels on the points themselves, so that the graph now will be self-documenting, a self-documented graph, in a sense. And by removing the legend, I am removing some graphical elements that are not strictly needed, which means that I'm improving the signal to noise ratio of this entire graph. Okay, so here you can see I'm removing those labels, and now I am writing this text using those, I'm providing those text labels using these two lines. So I'm basically saying ax.text. I provide the x coordinate of this text, the y coordinate of this text, and the y coordinate is the y coordinate of the upper line, here it is. And I put it a little bit below the line, hence you can see here this minus 0.1. And I provide the label itself, it's a baseline. And those two elements at the end of those commands, those elements, those arguments provide the alignment. So I'm telling here HA means horizontal alignment is center, which means it's center aligned, and VA means vertical alignment, which means which tells matplotlib how to align this text label in the vertical dimension in respect to this y coordinate. Okay. I also, and this is the final step, I reduce the amount of ticks on the x-axis. So right now I only have 2 ticks because it's a linear axis. We don't need more than that. So I have 2 ticks, and those ticks are the actual ticks that represent actual numbers. So we know that the minimum value in this data set is 0, and the maximum value in this set is 0.9. So now the graph is much cleaner, and it contains more useful information and less useless information. Okay? You see on your screen now the URL of the repository that contains this graph in this notebook, and I hope you like it. And if you like it, just write me or leave a comment. If you don't like this, again, write to me and tell me what I can improve. See you.